Hello everyone, so this video is just going to go over a few points in preparation for tomorrow's exam. The first thing that I want to discuss is that the equation sheet is posted on Canvas. It was posted on Canvas yesterday, so it is available for you to download. And so before you start the exam tomorrow, you're going to want to make sure that you have the equation sheet somewhere readily available. You can have it opened in a different browser tab if you want. You can have it opened inside of a PDF viewer application, so Acrobat or similar. Excuse me. And then you can make sure that you can easily access it as you go through the exam. Also, if you do have access to a printer, you could feel free to print a paper copy of the equation sheet and have that at your desk as you're going through the exam. So from here, I do want to just discuss the format of the exam a little bit. So we will switch over here to this example question that I've set up. So the multiple choice true-false questions are going to be exactly like the quiz questions, so you should all be fairly familiar with answering those by this point in the semester. But what's going to be a little bit different is the way that the calculation questions are handled. And so here is a sample question. This is a question from homework number 7 that I've put into the quiz format that you will see on the exam tomorrow. So let's get rid of that real quick. Okay, so this is just a sample question. So one of the kind of shortcomings of the Canvas quiz system is it's not really set up for multi-part questions. So I had to break any kind of multi-part question that I wanted to ask you into separate quiz questions on Canvas. So in order to keep you all aware of which different actual quiz questions are part of the same overall problem, I made sure to give each of them a title and then label the particular part. So we can see here I've called this question rotating wheel, and here is part A. And so then you're given the information for the question. A 76 centimeter wheel accelerates uniformly about its center from 110 RPM to 260 RPM in 7 seconds. And we want to calculate the angular acceleration of this wheel. And so to answer this, you've got a little answer blank here, and Canvas is then set up with what the correct answer is, as well as a tolerance to give a range of kind of allowable answers to account for any differences in rounding and how you perform the calculation versus how I perform the calculation. So I'm going to enter the answer here. So for this particular problem, you should get 2.244 radians per second squared as your answer. But we don't want to enter any units in here. We can only enter the numerical answer. So don't bother putting in any units there. And then immediately following this numerical question, you'll see there's this rotating wheel, part A, reasoning. And so in here, what I want you to do is explain how you arrived at your particular numerical answer in the previous part. And so this is effectively showing your work for that calculation. So what we can do here is we can just explain what we did in order to solve this problem. So we can say something like uniform acceleration means constant acceleration. And then you can say, we can find the average acceleration by taking the difference between the initial and final angular velocities over the time interval. And then we want to, explain in a bit more detail than just that. So right now I've just given kind of a basic overview of the approach. And then here I could say, first I converted the speeds in RPM to radians per second. Then I plugged the numbers into, and we can point out which equation that we used. So if we go back and take a look at our equation sheet, you'll see all of the equations have a number after them. So I don't need to enter the specific equation. I can just type out what equation number I used. And so for this particular one, we've already said that we're going to take the difference in our angular velocities, the change in our angular velocity divided by the time interval, and that gives us our average angular acceleration. And so we can see that is in equation 25. And so then we can say, switching back over to our canvas, we can say here, then I plug the numbers into equation 25. Okay, so then that is telling me that which equation you were using, and you've explained kind of at this point what it is to do to solve that particular part of the problem. Now, you could, if you really wanted to, potentially enter an actual equation into this so that you do have access to an equation editor. So this little square root of x symbol here will bring up the equation editor. And so you can go through and you can format equations in here, but that will probably take too much time, so I don't really recommend that you do this. So instead, like I said, just stick to typing out in words what your reasoning behind solving the problem was. You can point to specific equations that you've used using the equation number from the equation sheet. And then that lets me know how you solved that particular problem. So when you submit your quiz, your exam on Canvas, it should automatically grade all of these problems here for the numerical answers, and all the multiple choice true-false questions will be automatically graded. But then I will have to go through and read all of your answers here and decide how many points your explanation of your reasoning is worth. Okay, and so then just to show, so when we go to the next part of this, this is all still part of the same problem. Here it's just asking what is the angular velocity of the wheel at 3.5 seconds. And so you can see I've labeled this rotating wheel part B. And so what that tells you is you can go back to part A, and we can make use of all of the information that's given in part A of this question. So things like the size of the wheel and the initial and the final velocities and the time interval. And it also then means we could use this angular acceleration that we calculated in that part to help us solve this part. And so again, you'll just work out what the numerical answer is, enter the numerical answer here, and then you can see below that we have part B, reasoning. And so then you do the similar process. You explain what it is you did to arrive at your numerical answer. So when you sit down to take the exam tomorrow, I would recommend that you have some paper available so that you can actually solve out these problems. You can do your workout on a piece of paper to arrive at your numerical answer, and then also make sure again that you have some easy way of viewing the equation sheet as you're working through the exam. So this has all of the equations that you will need in order to solve all of the problems on the exam. There are some other cases where, so for things like the moment of inertia of particular types of objects, those are given usually in the problem text itself. So you don't see any of them on here, but you will still be given that information. So you don't need to memorize, say, like what the moment of inertia of a sphere or disk actually is. Okay. So, again, just to be aware of this kind of separation of the problem into these multiple questions. But again, I did label everything, and so hopefully it will be clear what is what questions belong to which particular problem. And during the exam tomorrow, I will make sure that I am available on Zoom. So if you have questions that come up during the exam, you can jump into that Zoom meeting room and you can ask me the question that you have. Okay, so I think that is everything that I have to say for now. So until next time, and good luck on tomorrow's exam.